as usual, first let's find our domain. We can clearly see that because of this, x cannot be -1 or 1. So on our number line, at these points, we have blank circles. Now, this already gives 3 columns to our table. Next step is to find the derivative of the function. For that, it's easier if we rewrite the function as 1 minus x squared to the power of -1. So the derivative of the function is -1 times 1 minus x squared to the power of -2 times -2x, which is nothing else but 2x over 1 minus x squared squared. Now we have to find the zeros of the derivative function. For that, we only have to consider the top of the function. So we get an equation like 2x equals to 0, so x equals to 0. Now this is a critical point, so on our number line it's a full circle, which means that 0 have a column on our table. Now we got intervals like x smaller than -1, x between -1 and 0, x between 0 and 1, and x is greater than 1. Now we know that at 0 the first derivative function is 0, and we have to find the signs on these intervals. For that, since this one is positive, we only have to consider this function, which is a linear function, and its graph is a line. What should look like this? Now we can clearly see that here our function is negative and here is positive. So let's put these signs back into our table. Here we have negatives, and here we have positive, so as well here. Now, according to these rules, our original function is decreasing here and here, and increasing here and here. Now, it wasn't the question, but we can clearly see that here we have a local minimal place. Now, according to the domain, at -1 and 1, we have dashed lines, which cannot be crossed by the original function. Now, according to the table, we can see that here it's decreasing, here it's decreasing as well until 0, from then increasing, and after 1 increasing again.